Hey guys, today we are going to talk about the very famous Pythagorean Theorem. Okay, so before we can do that, we got to make sure we can identify the sides of a right triangle. So the sides of a right triangle is special names. You have legs are the sides that meet at the right triangle. Okay, so here's the right angle, sorry. Here's the right angle. So one of the legs, this would be a leg right here, we'll call it leg 1. And then this would be another leg right here, we'll call it leg 2. And then the hypotenuse is the side that is across from the 90-degree angle. It's the opposite of it, so this would be the hypotenuse right there. Okay. So remember, the two legs always meet at the 90-degree angle. The hypotenuse is the other side. Okay, so those are your sides. Now here we have the Pythagorean Theorem, and it says, notice it's in a big pink box because it's important. The square of the hypotenuse is equal to the sum of the squares of the two legs. Okay, which basically means that if I take the first leg, leg 1, and I square that, and I add that to leg 2 squared, then I get the hypotenuse squared. Okay, it's very often written like this: a squared plus b squared equals c squared. Now I don't usually use this because if for some reason these got moved around, so here's A, here's B, and here's C. If I move these around, then people still use a squared plus b squared equals c squared, and that might not actually be the case. I mean, obviously if I move this over here and I move this over here, now c squared plus b squared equals a squared. Okay, so that's why I usually go with the first leg squared plus the second leg squared equals the hypotenuse squared. Okay, now, this wouldn't be any fun if we didn't prove the Pythagorean Theorem. So here's a clever way that somebody showed to prove it using algebra. So you take a big square like this, okay, and you put another square in there like this. And so that it forms these four equal right triangles right here. Okay, so this is A, this is B, this is C. So here's my right triangle. Okay, and I'm going to show that a squared plus b squared equals c squared. And here's another one exactly like it. Here's another one exactly like it. Another one exactly like it. So the area of this square in the middle is c times c, which is c squared. Okay, and what we're going to do is we're going to show that a squared plus b squared is c squared. Now, how are we going to do that? Well, first thing we're going to do is we're going to figure out the area of the big square. Okay, so this side of the square right here has a length of a plus b, and so does this side over here. So since the area of a square is the base times the height, okay, we're going to take a plus b and we're going to square that. Okay, so it's a plus b times a plus b. Now if I work this out, that's a squared plus 2ab plus b squared. Now how do I get that? Okay, let's just go off to the side over here and take a look. Oops. For just a second. So if I take a plus b times a plus b times b is b squared, b times a is ab. Then I leave a space and I move over. This is just multiplication, right? A times b is ab, a times a is a squared, and I add these up, add up my like terms, so I get b squared, I get 2 ab's, and I get an a squared. So this becomes this, okay? That's the area of this big square right here. It's a squared, whatever this is, squared, plus 2 times a times b, plus this side squared. Okay, now, here's what I'm going to do. I'm going to take these four triangles and I'm going to cut them off of this, okay? So the thing I need to do is I need to calculate the area of these four triangles. So let's do that next. the area of the four triangles would be 4, because there's 4 of them, half the base times the height, right? So here's the base and here's the height. Okay, so 4 times 1/2 is just 2 times AB. So the area of the four triangles is 2AB. Now here's the thing, if I take the area of the big square right here, which we said was this, and I subtract off the areas of those four triangles like that, I'm left with the area of this square right here, right? Which we already know is c times c, which is c squared. But if I take this and I subtract this, okay, here's my a squared plus 2ab plus b squared minus the 2ab, that just makes these kind of cancel out right there, and I'm left with a squared plus b squared, and hey, we already know that that's c squared right there. So I've shown that a squared plus b squared equals c squared. How exciting. You can't get this in PE or English or social studies. Okay, so now that we know that we have this theorem and that it works, we can use it to find the length of a hypotenuse of a triangle. So here we have a right triangle, here's a leg, here's a leg. We know that these are the legs because they meet at the right angle. And so what I can say is that 5 squared plus 12 squared equals the hypotenuse squared. And 5 times 5 is 25, and 12 times 12 is 144, and that equals c squared. These added together is 169, which is c squared. Now I can square root both sides, so the square root of c squared is c, and the square root of 169, everybody knows, is 13. So this has to be 13 right here. Okay. So we were able to, even though we didn't know it, we knew the two legs, we were able to calculate the hypotenuse. Okay, so now you try these. So I've got an 8 foot side, 15 foot side, what's C? And I've got a 3/10 and a 2/5 sides, and I need to have you find C here. So pause the video, figure these out, and then jump back on here and see how you did. Okay, this one we'll do first because no fractions, right? So it's a little bit easier. So it's leg squared, 8 squared, plus the other leg squared is 15 squared, and that's going to equal the hypotenuse squared. Okay, so c squared is going to be 64 plus 15 squared is 225. Okay. Now, if I add these together, c squared is going to be 289. And when I square root that, I'm going to get, what is that, 17? Okay, so it's going to be 17 feet. Okay. So, hopefully you got 17 for that. And it's in feet. We have to use the units because we've got them on here. All right, this one doesn't have units, so we don't have to worry about this one so much. Okay, so here we've got a hypotenuse is the c again. So c squared equals this leg squared, 3/10 squared, plus this leg, which is 2/5. I'm going to square that. Get rid of the stray dot. Okay, now this gets a little tricky. C squared, this is going to be 9 over 100, because we remember we square the top and we square the bottom. So then over here, I'm going to square the top, that's 4, and the bottom's going to be 25. Now I got to get a common denominator here, so before I can add these together. So c squared, that's going to be 100. It's going to be my common denominator. So let's see, I multiplied that by 4 to get that, so this is going to be 16. And I add those together, and I'm going to get 25 over 100, which I can reduce because 25 will go into both of those. That's 1/4. All right, now this is tricky. When I square root 1/4. Okay, so this is going to be the square root of 1/4. The square root of 1 is 1, and the square root of 4 is 2. So C ends up being 1/2. What fun that is. Okay, moving right along. All right, not only can you find a hypotenuse, you can also find a leg. Okay, so let's find the leg here. So here's a leg squared, x squared, plus another leg, 2.1 squared, is going to equal the hypotenuse, 2.9 squared. Okay, so of course, I didn't bring my calculator, so let me pause this video real quick and grab my calculator. Okay, so let's go ahead and finish this up. We've got x squared. 2.1 squared is 4.41. 2.9 squared is going to be 8.41. Okay, so now we're going to solve for x. We're going to get rid of this. We're going to move this to the other side. We're going to get x squared is going to equal 4. And that's easy because x is 2 when I square root that. Okay, so this side's got to be 2. So piece of cake. All right, so I can find a leg or I can find a hypotenuse using the Pythagorean theorem. All right, you're playing capture the flag. You are 50 yards north and 20 yards east of your team's base. The other team's base is 80, I should say yards, not years. 80 yards north and 60 yards east of your base. How far are you from the other team's base? Okay, so we've got a little graph here. All right, here's you. Here's your base right here. Here's you. You're 50 yards north and 20 yards east. Okay, and the other team's base is 80 yards north. So 80 yards north and 60 yards east of your base. Okay, how far are you from the other team's base? So basically what you have to do is you have to calculate that distance right there. Okay, so I can do this. I can say, okay, this is a distance of 40 right here. So it's 40 yards east and it's 30 yards north. So now I can do a Pythagorean theorem thing. I can say, okay, 40 squared plus 30 squared equals c squared. So c squared is going to be 1600 plus 900. C squared is going to be 2500. And then I'm going to square root those. And I'm going to get c equals 50. And that's in yards. Okay, so this has to be 50 yards right here. Okay, before I cut you loose on your assignment, I'm just going to put an extra little page in here and talk about something called Pythagorean triples. Pythagorean triples are convenient to know. You don't have to know these, but they're convenient, okay? So, what are they? They're 3 whole numbers that work in the Pythagorean theorem, and they come in sets. So, the most famous is the 3, 4, 5 right triangle, because 3 squared plus 4 squared is equal to 5 squared. 9 plus 16 is 25. 25 equals 25, okay? So, this is a Pythagorean triple. It's also the only one that's 3 consecutive numbers. Now here's the beauty about this. You can find another Pythagorean triple by just doubling all these. So 6, 8, and 10 will also work. I can triple it. 9, 12, and 15 will work. I can quadruple it. 12, 16, and 20 will work, and I can just keep doing that. Okay, these are all Pythagorean triples. Now, like I said, they come in sets. Okay, so another set is the 5, 12, 13. Okay, 5 squared plus 12 squared is 13 squared. We already did this one. 25 plus 144 is 169. 169 equals 169. Okay, now I can find a whole other set of Pythagorean triples by doubling this. That'd be 10, 24, 26, and tripling it, 15, 36, 39, and so on and so forth. Okay, so I can find all kinds of Pythagorean triples. Now, people always seem to think that 1, 2, and 3 are a Pythagorean triple, but they don't work. Okay, let's look. 1 squared plus 2 squared is not equal to 3 squared. 1 plus 4 is not equal to 9. So 1, 2, and 3 are not a Pythagorean triple. Okay, so they can be very helpful at times. And that's what I got for you today. So here you go. We're going to do 1 through 23 odd for our homework. And I look forward to seeing you guys in class.